Alright, so next example, for example 6. Okay, the Fourier series is given, right? So the Fourier series here is given, and you have to know, first thing is you have to know what is the types of function there, okay? And then what is the shape of the graph in order to determine whether it is even, odd, or neither, right? So, anyone want to try here? Is it even or odd for this case? Okay, is it even or odd? I'm not going to show this one by one, so better you understand this. Example 6, 7. So as for today, we're going to proceed with how to obtain this Fourier series expansion here. Okay, anyone? How can we determine is it even or odd? By doing what? You have to plot, right? So first thing first, what is your L? And what is your T? T equals to pi here, right? Okay. And then L is, or L is given by E over 2. So same, pi. So now you know your pi, now you know your L, and you need to determine the type of the function here. And the most easiest part is to plot. Okay, so what is the shape of sine? From minus pi over 2 to minus 2 pi. Okay, first, what is the graph of sine we have here? Like this, right? But now we have modulus. So this is pi to pi. This is pi over 2. This is negative pi over 2. So we want to consider only from negative pi over 2 to pi over 2. So what can be done by this modulus is to reflect the negative value to positive, right? So the shape of the graph is within this range, means that it is this shape. Okay, where this is your reflection line, the symmetric line, and as you can see, it is symmetric about So when it is symmetric about y exists, then we can conclude that your fx is even. Okay, clear? So once it is even, then you proceed with formula. First, second, or third? Second. Okay, good. So now by using the second formula, try to show that the Fourier series of this function is given by this. So your answer is given here. You need to show. Okay, try. So if it is even, then you have to consider the second formula. Means that what you need to find is only A naught and AN, right? This is the second formula here. This one. Okay, is that clear? Any question? Okay, try. So this is second formula. So what you need to find here is A naught and AN. Then you substitute to the Fourier series to obtain this. Okay, try. If you have a question, you can ask. Today's class is just about discussion. All right, so now you know that we have to find A naught and AN. Okay, so usually A naught is easy, right? Okay, I think everyone has no problem with finding A naught, which is A naught equals to what? Okay, A naught equals to 2 over L. L is pi over 2, so we will have 4 over pi, right? 2 over pi over 2, so it is 4 over 5. Okay, and then integrate from 0 to L. L is pi over 2, and your fx is sine x dx. Right, so integrating this, we will have 4 over pi negative cos x from 0 to pi over 2. Substitute will give you 4 over pi. Okay, everyone has no problems with finding A naught? All of you got A naught? Okay, good. So now let's find AN. So from AN, you know that it is 2 over L. So it is still 4 over pi. From 0 to pi over 2, fx is sine x. Cos nx over L is cos n pi over L is n pi over 2 will have cos 2n x dx. Is it? And pi over 2. So just put 2 here and then we eliminate pi. So we will have 2n x dx. Okay. So now this cos x 2n x here is we can use identity. Okay, where this is what? Just put this 4 here. Just factorize this 4 here to 2. Okay. Then we will have here 2 sine x cos 2n x dx, where we can have 2 sine x cos 2n x as 2 sine x cos y. All right, where it comes from the identity of sine nx plus sine x plus y plus sine x minus y. So from here we can have sine x is x, y is 2 and x. Okay. plus with sine x minus 2nx. So this is from identity. Okay. All right, you can also use 1 minus 2 sine square x. So the problem here will be about the process of integration. So we use addition and subtraction here in order to ease the process of integration. Okay, now just substitute. Here is 2 over pi, 0 pi over 2. Now this one becomes sine x plus 2nx plus sine x minus 2nx. Yes. So it is easy for you to integrate this. Okay. Now you will have integrating this, you will have what? 2 over pi from 0 to pi over 2. Sine becomes negative cos x plus 2nx divided by 1 plus 2n. Then this one also minus cos x minus 2nx divided by 1 minus 2n. Okay. Okay. Are we good? Can you follow this from here? Okay, next, just simplify. So here we have what? 2 over pi. So substitute everything here with the limit given. Negative cos pi over 2 plus 2 and pi over 2, right, over 1 plus 2n minus with cos pi over 2 minus 2n pi over 2 over 1 minus 2n minus negative cos 0, right? Minus cos 0. Okay. Substitute one by one to your x, right? So substitute here to your x. This is x. And then this one, x plus 0 plus 2n times 0. So 0. 0 minus 2n times 0, 0. So that's why it's 0 there. Okay. And then simplify. So from here you simplify, what should you get? Okay. So this one cos 0 is 1, right? And then this one only simplify 2n with pi over 2 here. Right? And then we can see here this is by using identity again. Cos pi over 2 plus n pi will become cos pi over 2 cos n pi minus sine pi over 2 sine n pi over 1 plus 2n minus cos pi over 2 cos n pi plus sin pi over 2 sin n pi over 1 minus 2n. Okay, then plus 1 over 1 plus 2n plus 1 over 1 plus 2n. Okay, and then this one is 0, 0, 0, and 0. Okay, can you follow this? Second part of cos fx, which part? Which part? The green one or the blue one? Integrate sign. Integrate sign. Which sign? This one? Is it this one? This one? Green, second row. Sine, cos. Is it this one? You mean? Oh, okay. Integrate sign, you get negative cos, right? Then plus, again, negative cos. That's why it is negative. Why it should be positive? So plus, minus, minus, right? Okay, clear? Mabuk dah? Alright, alright. It's okay. If you have problem, you can ask. Okay. Now, are we clear up until this? This one, we apply identity, right? This one, identity. So now, here we have 0, 0, and then now what's left? What's left is 2 over pi, 1 plus 2n plus 1, sorry, this is minus, minus, right? 1 minus, okay? So equalize the denominator. We have here 1 minus 2n plus 1 plus 2n, and everything 1 plus 2n. 1 minus n. So we should have 1 minus 2n plus, so we will have 2 over pi, 2, and then this one, 1 minus 4n squared, right? So for 2 times 2, we will have 4 over pi 1 minus 4n squared. Okay, so this is your an. Okay, an is 4 over pi 1 minus 4n squared. So now substitute to the Fourier series, we have a naught over 2 summation an cos n pi l of x. So fx is a naught over 2, 4 over pi over 2 we will have 4 over pi is your a naught over 2 plus summation of n equals to 1 to infinity 4 pi 1 minus 4n squared cos n pi over l, right? N pi over lx. N pi over 2x. So we will have 2 over pi minus, this one is constant, just put outside. Okay, this is positive, just change it to negative in order to show it is equal to the given series there. Okay, cos 2nx. Okay, if it is just finding the answer, no need to change the sign there. But here we have to show it is the same with the given expression. Okay, is that clear? Or you want to take a review about this? But here is not enough. We start from here. All right, can you see it clearly here? Positive, negative before sigma, which part? Second last row, how do we determine if we have positive, negative before the sigma? This one, is it? You mean by this one? That is from the formula, right? We just plus there. We just plus there. So just plus with what you have. Okay. Now I change this positive to negative because we want to make sure that it is equal to the given expression here. When this one is negative, then you just change the expression instead of 1 minus 4n squared. Now it will become 4n squared minus 1. If it is just finding the answer, if you stop here, then it is correct. Okay, no need to change the sign. But this one is for the solving purpose. Is that clear? Okay, good. So I hope this can give you a view of the whole process. I hope you can see it. Oh, I missed something? I think no. This is the green one. Up until here, an, and then fx. Okay. Right, try to understand first. And then if you have question, you can ask. Okay. Okay, example 7 here, identify what? Identify L, identify T, and identify the shape of the graph to determine whether it is even, odd, or needed. Okay, what is your T? T is easy, but usually T is not given. Okay, so usually T is not given, then you can evaluate T from the given range, where range here is from negative L to L. So when L equals to pi, you know that uh, L equals to T over 2. So T equals to 2L, T equals to 2 pi. Okay, so L is pi, T is 2 pi. And then plot the graph in order to identify the types of the function there. So when x is from negative pi to 0, fx is x. When x is from 0 to pi, fx is 0. So what is the shape of this graph here? We have here, when x is from negative pi to 0, the shape of the graph is x. So x is here. So this one, right? From negative pi to 0, and then from 0 to pi, fx is 0. So this is the shape of the graph. And then it is repeated for every t equals to 2 pi. Okay, are we clear? So from this shape, what can you conclude? Is it symmetric about y or origin? If it is symmetric about y-axis, then this should be your symmetric line, right? But is it? Is it symmetric? No, right? Okay, and then when it is symmetric about the origin, either it symmetric line is here or here. But is it symmetric? Still no. So you can conclude that the function is neither even nor odd. So you have to come to the first formula where you need to find all A naught, AN, and BN. Is that clear? So we have discussed case 2 and case 3. Now this is case 1, where you have to find all the values of A naught, AN, and BN. But how to find is, of course, the same one, the same process. Okay? Okay, try it. Now this is neither, so you have to have full Fourier series consists of A naught, AN, and BN. Alright? So your A naught is what? A naught equals to, what is the formula here? 1 over L minus L to L of x. So A naught 1 over L minus from minus L to L fx dx. So L is pi. Okay, so here from minus pi to pi. So you have to do it one by one, right? So from minus pi to pi, you should start with minus pi to 0 first. Okay, you know that this is minus pi to phi of fx. But here from minus pi to pi, we have two functions. Okay, then from minus pi to 0, fx is x, right? And then from 0 to pi, fx is 0. So this is how you find A naught. Okay, clear? And then an, how to find an? An is still 1 over L minus L fx cos n pi x. Same process, right? Okay, try to find it. And you know that the second function here is 0, then automatically you know that this is 0, right? So this one you just proceed with minus pi to 0 only. No need to have 0 to pi because the function is 0. Okay. Okay. So once you got A naught, AN, and Bn, just substitute to the Fourier series expansion, Fourier function there. Fx is what? A naught over 2 plus. Okay, check the answer here. Okay, I'm going to leave you with this example. You can try and try to obtain the answer here is given. Okay, if you have problem, you can ask me. Okay, is that clear? All right. Okay, before we stop, don't forget to scan your attendance here.